In today's video, we are going to discuss another important topic of neural network, that is perceptron. So let me discuss what perceptron is. Perceptron was basically developed by Frank Rosenblatt. There was another model that is called Makula-Pitts model or MP model that we have already discussed in previous video. In basically using the concept of MP model, perceptron is being developed. It is basically the basic operational unit of artificial neural network. It basically employs the supervised learning rule and is able to classify the data into two classes. So if we have a lot of data available there, it can classify it into two parts, right? What we have discussed in MP, just remember that one. We have different inputs, but those inputs were binary only. So binary inputs were coming. We don't have any concept of weight there. Those inputs are coming to any specific, say, a processing unit. That processing unit basically checks the total sum of that weight. If it is greater than threshold, it allow it to fire. Otherwise, it will not allow it to fire. So we are using the same concept in perceptron but with some modifications on that one. And what are those modifications that we will discuss later on. Another thing, in MP neuron there was a concept of linear separability, that in same concept perceptron also classify the data if they are linearly separable. And which data we are calling linear separable? The data in which we can separate them by drawing a straight line in between of them. So if we are able to draw a line, a straight line between the data, and we can separate them by using that line, we can say that data is linearly separable. As you can see in this example, if we are saying we are having a straight line and that can differentiate these two into two different parts, we are saying it is linearly separable. This data is linearly separable by this line, this data is linearly separable by this line, and again this data is also linearly separable by these two specific lines, right? But here we are having a concept in which we cannot differentiate them by using one single line, and that's why this data is not linearly separable, right? Same, if we have AND function like this one, we all know that in AND, if 1 and 1, that is true, otherwise in all every cases it is false. So we can draw a line in between them like this one, and we can linearly separate into two different parts, two separate parts. Okay, one at one side and zeros on other side. Same for OR. We can draw a line like this one, and we can separate them into two different parts. But in case of XOR, we cannot do that. As you can see over here, we cannot draw a separate line, a single line by which we can separate these input data into two different classes or two different parts. So this is not linearly separable. What are the characteristics of perceptron? It basically consists of a single neuron. Like in this case, this particularly say about a single neuron. It is having one single neuron, but inputs are arbitrary. We can have as many number of inputs as we can, and they are having some adjustable weights. This is basically the difference between perceptron and MP neuron, that the weights here are adjustable. While in MP neuron, we don't have the concept of weights basically, or even if we are putting weights, they are of same weights throughout. And second, the output of this neuron is 1 or 0. That means it will present a binary output depending upon the threshold. What will be the value of threshold that we have already discussed. It also consists of bias. As you can see over here in this diagram, we are having a concept of bias. This is another input, a separate input, which is having a weight 1 always. Okay. So with value 1, we have a bias. We have different other inputs which are having different adjustable weights. So what is happening? Inputs are coming from here. This adder is going to add them. Bias is also going to be added with that input. Then it will be passed to an activation function, and that activation function will return you the output. Activation function we have already discussed in separate video. Okay, so what are the difference between MP neuron and perceptron? We already have discussed that it overcomes some of the limitations for MP neuron by introducing the concept of numerical weights. Okay. Uh, what we were discussing, that in case of MP neuron, there was no concept of weight, or even if we are putting weight, they are of fixed weight, say 1. In all the inputs are having same weights in that case. But here we are having numerical weights as well as they are adjustable. Second, inputs are no longer limited to Boolean values. Like in MP neurons, there was all the inputs were in Boolean formats. But now in perceptron, the inputs could be non-Boolean as well. So these are the two difference between MP neuron and perceptron. One is the concept of weight, adjustable weight, and another is the Boolean inputs. So guys, in this video, we have discussed what perceptron is. And in upcoming video, what we are going to discuss is we are going to take an example, and then we will put that perceptron concept on that example, and then we will solve it up. So guys, till then, please like and subscribe. Thank you very much.